Let's have a look at triglycerides. So triglycerides, basically triesters. So in biology we regard these as fats, and you might remember from digestion that fats get broken down into fatty acids and glycerol. Well, that's how we'd make them up. So glycerol is a triol, so it has 3 carbons, and on each of the carbons there's an OH group. So let's have a look at the structure. So quite a small molecule. And on each of the carbons, there we go, we've got 3 OH groups, which give it a lot of hydrogen bonding, which make it extremely viscous. So a bit like treacle glycerol. So that's propan 1,2,3 triol. The other component of a triglyceride is a fatty acid. So they're basically carboxylic acids with a long chain. So the first one, octadecanoic acid, sounds complicated, so it just means 18 carbons in the acid. I'm going to draw this one skeletally. You'll tend to see them drawn skeletally. So that's going to be carbon number 1. Let's count through. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 carbons in octadecanoic acid. So that's a saturated chain. You might choose to illustrate it by just drawing the structural formula. You'd probably put all the CH2s together like so, and it's got 18 carbons altogether. So we've got 1 in the CH3, 1 in the carboxylic acid group, which means that we need 16 CH2s. What's different in the next one then? So we can probably see that now it's gone from decan to decene. So this has got a double bond, and the 9 tells us it's on the 9th carbon of the chain, counting back from the carboxylic acid. So that's number 1, 2, 3, 4, 5, 6, 7, 8, 9. So we want a double bond on that 9th carbon, which was there. So simply just show the double bond like so. Now we obviously can get EZ isomers here. I've just highlighted the one that I've drawn. Don't draw the hydrogens in your skeletal formula, but hopefully we can see that the way I've drawn, my priority groups are not going to be the hydrogens. The highlighter's not behaving itself, it keeps falling off, but those priority groups are across from each other, so that is an E isomer. How would you draw a Z isomer? Well, like that. So a little bit like a picnic table, and there we go. So there's the Z isomer where the priority groups are across from each other. What's going on in this final example? Well, it's a diene, so we have 2 double bonds on the 9th and the 12th carbon, so you just need to be careful with your counting here. 18 again, that's number 1, 2, 3, 4, 5, 6, 7, 8, 9. To the 10th, I've drawn that as a Z. 11, 12. Let's draw that one as an E. They will tell you in an exam which one they're expecting you to draw. So, how do we put together a triglyceride in an equation? So we need to use plenty of space. So I'm starting off by showing you the structure of glycerol again. This makes it a little bit more obvious how the ester links are going to form, and for each of those OH groups in the glycerol we need a carboxylic acid group. So we need a long chain fatty acid. Let's go for octadecanoic acid as it's said, so that will have 18 carbons in total. Here's the structure of the product. So carefully illustrate each of the ester links. This is the first thing that the examiner will be looking for, and then I'm just attaching my long chains. So 16 CH2s and my CH3, and I've got that on each of the ester links. So that's the structure of my triglyceride. So that's made from each of the carboxylic acids is the same. Do I have another product? Yes, I do. So at each of those points has been a condensation reaction, so I get 3 waters as well. Kind of the opposite now, so we're going to be breaking down a triglyceride via hydrolysis. We've looked at the hydrolysis of an ester, breaking esters up, so we're just going to be doing the same here. So there's our 3 ester links that we want to break. You can see on the left hand side our alcohol that we'll go back to will be glycerol, and on the right hand side we're going to get 3 carboxylic acid molecules. The method of hydrolysis, though, using sodium hydroxide, when the ester links break, we will indeed go back to our glycerol, but we just need to be careful about the carboxylic acids. So here's our glycerol. So the carboxylic acids that we've got, no problem with the chain, but then remember that under alkaline conditions we're not going to see the carboxylic acid, we'll see the carboxylate salt of the carboxylic acid. So a long chain carboxylate salt will serve as soap.